Welcome to the third video of lesson number 1 in Unit 5. In this video, we will review the concept of equivalent fractions. So what are equivalent fractions? Well, these are fractions that represent the same part of the whole. The numerators and denominators, they'll be different, but the overall fractional value will be the same. To further study this concept, let's look at a few diagrams. So first of all, we have here the number line. Actually, that was in the second video. It's been labeled 0 to 1. We have 10 equal sections in between. Here we've put two 1/5 fraction strips, which would in turn give us the fraction 2/5. Right here, below the yellow ones, we have 4 fraction strips that are 1/10 each. So that would give us 4/10 in total. And what we need to pay particular attention to here is the fact that these fraction strips begin and they end in the exact same spot on our number line. So what that means is that 2/5 and 4/10 are the same thing. In other words, they are equivalent. Let's look at 3 sets of rectangles here. And we need to pay particular attention to the fact that each hole has been drawn the exact same size. That's very, very important when we're comparing. But when we look closely at each one, we see that they've been divided up differently. So in our first rectangle here, in the first hole, it's been divided into 4 equal sections. So that tells me my denominator is 4. 3 of those sections have been shaded. A numerator is 3. So the top one represents the fraction 3/4. In my next hole, number 2 here, this one has been divided into 12 equal sections. And we have 9 of those sections that have been shaded, thus representing the fraction 9/12. And then in the third rectangle, this one has been divided into 16 equal sections. And if you count up the total number of shaded ones, you will have 12. So all 3 have the same size hole, and the amount shaded in each one is exactly the same. So what we have then is that 3/4, well, that got to be the same as 9/12, which is the same as 12/16. So all 3 of these fractions are called equivalent fractions. One more series of diagrams here. 4 circles. And each of the holes, each big circle has been drawn the same size, but again, they've been split up into different numbers of sections. So in our first circle here, we have 3 equal sections with 1 shaded. In our second circle, we have 6 equal sections and 2 are shaded. In our third hole, we have 9 equal sections and 3 are shaded. And in our fourth hole, the fourth circle, this one has been divided into 15 equal sections, and we count 5 being shaded. Same size hole each time. Each of these circles is the same size. And if we look at the shading part again, the exact same amount has been shaded in each circle, thus leading us to the conclusion that 1/3 and 2/6 and 3/9 and 5/15 They are all equivalent fractions. They all represent the same part of the whole. So let's now look at a way that we can create equivalent fractions without having to draw them. So if given a fraction, one can create an equivalent fraction by multiplying the numerator and denominator by the same natural number. And if you recall, natural numbers are what we call our counting numbers. 1, 2, 3, 4, 5, and so on. What I call nice numbers. We can also create an equivalent fraction by dividing the numerator and denominator by the same natural number if the resulting numerator and denominator are also natural numbers. One thing we need to keep in mind, though, as we go through some of these examples now here in a sec, is that multiplying or dividing by 1 will not change your numerator or denominator. 5 times 1 is still 5. 8 times 1 is still 8. 10 divided by 1 is still 10. So if we were to go with 1, we're only going to get the same fraction back. So that doesn't really serve our purpose. So I've given here the fraction 1/4. We want to create at least one more equivalent fraction. We'll probably do 2 or 3 here. So I'm going to multiply here my numerator and my denominator by the same natural number. And we just finished talking about the idea that multiplying by 1 is no good because that just gives us the same fraction back. 1 times 1 would be 1. 4 times 1 would be 4. We get back 1/4. So let's go with 2. So I'm going to multiply numerator by 2, denominator by 2. Multiplication facts, always important. 1 times 2 is 2. 4 times 2 is 8. So that means that 1/4 and 2/8 are equivalent. I could have multiplied by 5. Numerator and denominator by 5. That would have generated the equivalent fraction 5/20. So 1/4 is the same as 2/8 is the same as 5/20. And there's an infinite number we could come up with. But 3/7. Let's go times 2 again. Why not? That's the easiest natural number to multiply by. So 3 times 2 is 6. 7 times 2 is 14. I could have started with 3/7 and multiplied by 10 and 10. Notice it's the same natural number that I'm doing each time. 30/70. So we could say that 3/7 and 30/70 and 6/14, they're all equivalent fractions. Now, thus far, I've only multiplied, and there's been a reason for that, and that's because 1/4 and 3/7, I cannot divide by a nice natural number and create an equivalent fraction with nice natural numbers. With 20/40, though, that changes things here. If I look at 20 and 40, I could, if I wanted to, divide numerator and denominator by 2. 20 divided by 2 is 10. 40 divided by 2 is 20. So 20/40 and 10/20 are equivalent. I could have actually, if you think about it, I could have divided numerator by 20 and denominator by 20. Because 20 goes into 20 once and 20 into 40 twice. If I go back to multiplication and I start with 20/40, I could double up 20, I could double up 40, and that would give me 40/80. So we've created a bunch of equivalent fractions here. So 20/40 is the same as 10/20, is the same as a half, is the same as 40/80, and like I said, there's an infinite number that we could come up with. Now I would like you to proceed to the next video in this lesson.